all the four combinations of two inputs. How many possible combinations will be there with the three inputs? I will come to chat box just to see are you able to follow it or not. With three inputs, how many possible combinations will be there? Yes, Anupar, right, 8. Very good. 8. Kushal, very good. Because 0, 0, 0, 0, 0, 1, 1, 0, 0, like that. 0, 0, 1, 1. So very good. You have got enough practice to solve the truth tables and all. So with the two inputs, it is four combinations. So I have written A into B. A into B is 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. So I have taken the complement of it. Then I have written A, B separately over here. A bar, B, A bar and B bar, A bar plus B bar, you can calculate 1 plus 1 is 1. Then 1 plus 0 is 1. 0 plus 1 is 1 and 0 plus 0 is 0. Since both of them are correct, equal, so you can write it down as the hence proved. Here actually it should have written as A bar and B bar, and corresponding to this, these bits will change. But nevertheless, this is a typo error. You have already solved it. I don't have to dwell on that. 46 students have given me the reply on the personal chat. So I hope that De Morgan's theorem, straight and true De Morgan's theorem, if this question comes, you will be the most happiest person to solve that. Then I have given you the other day some of the basic laws of Boolean logic, Boolean algebra, and those I told you the hint also that there is no need even to memorize, because in case of binary, Boolean is for binary logic, and in case of Boolean, there are only two possibilities. Either variable can be 1 or the variable can be 0. So when I say identity law, 1 into A is equal to A, you don't have to memorize also, because 1 into variable A, if I put it as variable as 0, 1 into 0 is 0. So whatever is the value of variable, that is A, that was 0, 0 has come. If the variable is 1, so multiplying by 1 is that variable itself, and the dual of that 0 plus A. Now what I have changed? I have changed 1 to 0. I have changed. Why it is called as the dual? Because I change both the places. I cannot make it as 0 into A is A. I have to change it at two places, as 1 का मैंने बनाया 0 and multiplication का मैंने बनाया add. So 0 plus A is A. So that is a what is it called as the dual of the theorem. It is quite obvious. You people can, without memorizing this table also, you can easily, while solving, you can, there is no need to memorize. You can, by your own, you can write down the simplification without noting down the or remembering the laws. It is as simple as that. 0 into A is 0. Similarly, I have made the dual of it. 0 का 1 किया मैंने और dot का किया मैंने add. 1 plus A is 1. Now, how it is 1 plus A is 1? Because A अगर मैंने 0 किया, 1 plus 0 is 1. A अगर मैंने 1 किया, 1 plus 1, that is OR operation. 1 plus 1, do not get confused again. It is not XOR, it is OR operation. 1 plus 1 is 1. So similarly, 0 into 0 is 0, 0 into 1 is 0. So null law is also. So A into A is A. So these are the laws which are, you can check it with the truth table. 0 into 0 is 0, 1 into 1 is 1. So A into A is A. A plus A is A. That is 1 plus 1 is 1, 0 plus 0 is 0. A plus A is A. It is as simple as that. A bar 0, A plus A bar is 1. AB is equal to BA, A plus B is B plus A. AB into bracket C is A into BC, that is associative law. So if you convert it into the dual form, it is A plus B plus C, A plus B plus C. So these are quite obvious. One of the law, distributive law is also common, that in case of decimal, whatever is there, like that we A plus B, BC can be written as A plus B into A plus C. Similarly, A into bracket B plus C is AB plus AC, correct? And then De Morgan's theorem we have already proven. And one more theorem is there, absorption theorem. Absorption theorem says that A into bracket A plus B is simply A plus AB is simply A. Now, this some of you may need to prove it, because some of you may not be able to do it with the truth table. It can be proven by the truth table and by basic laws also. So I hope that all of you are following what I am saying. And what I was telling is that why this simplification is required is because here I would have required OR operation followed by AND operation. But if I simplify by Boolean laws, I don't need any gate also. I just have to pass on simply input to the output. So that's how my combinational circuit by using logic gates gets minimized. So that is the beauty of this particular uh, uh, laws. And we are going to see today the introduction of Boolean logic simplification. I have attended the subject meeting for this particular subject, and more emphasis is on computer organization and architecture. You just have the introductory session of simplification of Boolean laws. You don't have even K-map also, K-map simplification technique. So many of the interesting parts they have skipped, but still only introduction to Boolean simplification they have asked to be taken in this particular first module, because from second module onwards only computer organization and architecture is there. So we will just solve 4 5 numericals, and with the help of that you will understand what is the need of Boolean logic simplification and how it saves the hardware. You have to use the hardware optimally so that with the reduced cost you can, if you want to travel from Palghar to say Santa Cruz, you can go by, you can say helicopter also. But is there any need? You can simply go by a car or something with the reduced cost. Always the intention is to minimize the cost so that whenever there is a bulk production at the cheapest rate, the hardware will be available. So I was trying to prove the absorption law, A into bracket A plus B is equal to A. So the dual of this I have proven. So this sample proof of absorption law is over here. X plus X into Y can be written as X into 1, because you know that multiplying by 1 doesn't change any of the value. So if I take X as common, 1 plus Y, anything plus 1 is 1. We have seen it in Boolean laws. So X into 1 is X. So A, B के variable की जगह पे they can ask X, Y. They can ask any variables, capital A, capital X, capital any variable they can PQR. But you should not get afraid because these are just variables. So either the laws are for A, I have quoted, the variable can be XY or the variable can be PQ or MN, any variable can be given in the exam and they may ask to simplify it. So let us see one numerical at engineering level ka numerical I have deliberately put at the outset, at the beginning only, little complicated, but if you reduce it, it will become very simple. So the numerical is like this: A into bracket A plus C into another bracket AD plus AD bar plus AC plus C. Like this is the given numerical and they have asked you to simplify. simplify the following Boolean expression. So how will you start? A plus C I have kept as it is. Then I have written in another bracket. I have started with the given numerical. Always you should start with the given numerical. So I have started. Then what I have done, A plus C into from AD bar and AD, I have taken A as a common. A I can take out as common. In bracket, what will remain? B plus D bar. Now, what we have learned in case of anything plus complement, you don't need to memorize this also. I told you many times. You don't need to memorize also. 0 plus 1 is 1, 1 plus 0 is 1, because anything add with its complement will give you the answer as 1. So in place of d plus d bar, I have written a into 1, 1 is implicit, it is into that only, plus AC plus C. Which law I have applied? I have applied absorption law. X plus xy can be written as x only. So AC plus C can be replaced by C only. So A plus C into A plus C. Okay. So now I multiply the bracket with A. It goes as AA plus AC, AA plus AC, and plus C as it is. Now from again, by applying the absorption law, AC plus C will become C, and A into A, anything into that thing, that is 1 into 1 is 1, 0 into 0 is 0, so A into A is A, so A plus C is your final answer. Now imagine uh, what is the use of doing all this is that in the given problem you would have required so many OR gates, you would have required so many AND gates, and now when you simplified it by using Boolean laws, you just require only one OR gate, and there is even no need of the input D, because it doesn't have any meaning on the output, so you can keep even giving input to your uh, circuit D as an input, because with A plus C also, whatever is the big uh, Boolean expression which was given, it has now reduced to just A plus C, A plus C. So that is the beauty of simplification by using Boolean algebra. Let me just introduce you a concept which is called as the K-map, Karnaugh map. It is applicable for 4 variables, 5 variables, 3 variables, 2 variables, and even more, but little complex. Then what they have done is that they have simplified and they have defined certain rules, and just by putting the numbers into the squares, you can just find out without applying Boolean algebras. You can, by using K-map also, you can simplify the Boolean expressions. So it is not there in your curriculum. It is specifically mentioned that by K-map there is no numericals are expected. So this is by using Boolean algebra. Now, some of you can uh, post the comment into the chat box whether the first numerical is understood. Yes, put it in the chat box. Whether the first numerical is understood, and are you, yes, 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 Jeet, Disha, Thumre, very good, very, okay, almost within uh, few seconds, so many students have replied. So I can, yes, Bharat Mai, yes, very good. So I will give you 2 to 3 problems uh, as a simplification, or I have compiled at least 20 problems, and with the solutions, I have solved it on my own notebook and I have shared with you, because I know that this topic will be of interest for you. So I have tried to cover as many numericals as possible. with you. So I will not put solutions directly. What I will do is a couple of we'll discuss two numericals and then I will post the unsolved problem into the chat box and then let us see how many of you are able to give me the shortest form of the Boolean algebra. So second numerical, I hope you have shown me your setup also many times. You people are with the notebook and pen. So I'm very happy. So AB plus ABC plus AB bar, prove that it is equal to A. They may ask you like this, or they may ask just to simplify the following without giving the final output. So how will you do? From AB and ABC, you have taken AB as common, C plus 1, anything plus 1, 0 plus 1, and 1 plus 1. I have told you the way it is 1 only. So AB will remain and plus AB bar will remain. So A into bracket B plus B bar, anything plus its complement 0 plus 1, 1 plus 0 is 1. So A into 1. So RHS is equal to A. As simple as that. So uh, for 10 marks, they give four such combinations and they ask simplify by using Boolean laws. So these are the easiest of the six modules wherein you should score full marks in this particular module. One and a half question is expected as per the discussion in the syllabus meeting. So you should acquire full marks in first module. So remaining theoretical chapters, even if you score little less in the remaining chapters, then also overall your score will be very good. So similarly, try to solve this data will be available with you, so you can practice it. Uh, so I mean to say that with simplification, you have reduced the number of logic gates required. So you can solve the fifth problem what I have given in this particular slide, because even if the variables are changed, do not get scared. For that, I have deliberately quoted the numerical in which you can find the variables. I have put it as x, y, z, w. So try to solve this, and then I will be coming to the chat box, and we will solve just two problems from the set which I am available with. So if you solve those two problems, then I can be sure that you can solve any numerical on Boolean logic algebra, and we can conclude today's session. I hope that you are very much enjoying this particular subject, at least the digital logic portion of the DLCOA. And of course, I will try to make it very, very interesting for subsequent topic also, although it is theoretical. I will try to make animated PPTs with which the concepts will be clear to you, so that you can feel how the computer is organized and how the architecture is made of the computer. So I hope that you people have solved fifth problem by referring to the notes little bit, but mostly on your own you have tried to solve. I have taken x common, and from the remaining you can see De Morgan's theorem also I have applied, and I have solved it by using the various identities which we had discussed. So if you have done, I will post couple of problems. These slides I will be sharing with you. Don't worry. Uh, I have compiled so many numericals. So many numericals I have compiled. So shall we come to the chat box and give couple of problems?